Thank you so much for coming out on what is a lovely evening to be with us this evening. My name is Peter Davis. I chair the Climate Change Commission for Wales, and we're hosting this evening in our role as a cross-party, cross-sector body set up by Welsh Government. 2007 the Commission was set up. I've been chair for the last two and a bit years as an independent chair of the Commission. The Commission role in Wales is to provide advice into Welsh Government, to mobilise action in respect of climate change, and to build an understanding in terms of the nature of climate change and the challenges that it brings us. I'm really pleased that we're here this evening, because I think it's something that we need to have more of, the opportunity to debate and understand and to challenge and to have a conversation around the nature of climate change. And I do want to thank David, as your MP, for, if you like, enabling this, and it's certainly something that I want to take forward in terms of conversations through MPs and Assembly members across Wales. I think we need to have more of that sort of conversation in terms of the issue that faces us. It's part of, and tonight is part of, and you'll see the banner at the front, a national conversation about the Wales we want. That is something that the Minister has asked me to take forward in my role as Sustainable Futures Commissioner for Wales. It's a concept which is around trying to shape the long-term goals for Wales. It connects to the Rio, some of you may be aware of the Rio process about the world that we want, the future we want. This is around the Wales we want, and other countries around the world are also taking this opportunity to have a conversation about the long-term goals that were linked into the United Nations, who are setting long-term sustainable development goals. And here in Wales, we've got this prospect of a Future Generations Bill, which will be introduced into the National Assembly in July of this year. And so this conversation is about what do we want for future generations, what's the legacy that we want to have for future generations, what are the measures of progress that we should be setting ourselves over the long term for future generations. And that piece of legislation is designed to ensure that the public sector in Wales take a longer term perspective in respect of the outcomes that we want for our children and our grandchildren. Of course, within that, there's probably nothing more important than being clear about the issues of climate change and the impacts of climate change. And tonight is an opportunity for us to have that conversation about the issues of climate change and the different views I'm sure that we've got in the room, and the issues that we need to consider. So my role is simply to welcome you and to say a big thank you to Mike, who many of you I know will be chairing this evening, to David, as I said already, who I think I particularly want to thank for enabling this evening, and also to James, who you'll be hearing from, who is somebody who has led the science in terms of climate change here in Wales. But enough from me, and Mike will now pick up the introductions and set the context for the evening.
Thank you, Peter. Okay, so yeah, welcome folks. I'll reiterate that to the beautiful St Mary's Priory. Those of you who don't know me, and I know there are a bunch of faces that I do recognise, as you know, this isn't my day job. I own and run Clanton Pride Court, which is about 5 or 6 miles outside of town. You also might have seen my little Moddy car outside, which is our Twizy. We have owned Clanton Pride for nearly 20 years now, and the sort of more common conversations you'll hear me having are about sustainable food, the sourcing of local food, production of local food, and how it gets used and consumed. So I was asked to chair a debate about climate. That was not exactly my main subject, but something I'm very interested in. So looking forward to this. If I could ask for your indulgence, we're going to kick the evening off with a little bit of introduction or some speaking from the two gents on my left. Then I'm going to ask you for some questions. I'll come to the rules about the questions in a bit. And then we're going to do some summing up afterwards. Hopefully we'll be all done and dusted by Hub State. So, without any further ado, I'm going to make some introductions now. officially Professor James Gorse. So James is over here. Those of you who are local will know that this is David Davis. With respect, James is probably not quite so well known locally. James Gorse, Professor of Marine Geology at Bangor University, currently Director of Climate Change Consortium of Wales. He completed his PhD in Marine Geology from the University of Cambridge in '85, which is when I left school, and was a research fellow at Girton College at the university before taking his role at Bangor. So we're going to ask James to go first, and he'll be followed by David. David is your local MP. I say your. I'd be interested. Put your hands up if you're from David's constituency. David's obviously got rented crowd in tonight. That doesn't necessarily mean you all voted for it. So David was in the Assembly initially, and then he became the Member of Parliament for Monmouth. In the general election in 2010, he doubled his majority to 10,000. He's now the chair of the Welsh Affairs Select Committee in Westminster, and he believes that, well, he'll tell you himself, but he believes that the Climate Change Act of 2008 may be one of the most expensive and irresponsible pieces of legislation ever. I'll let him explain why shortly. Okay, so, trying to keep to a programme. 15 minutes each, gents. Nice clean fight. Okay, so without the mic, I'm going to hand you over to James. If you can't hear, just shout. We can mic him up, but he's going to go for it without. Okay, folks. Professor James Gorse.
Okay, thank you very much. David, ladies and gentlemen, great pleasure to be here this evening. It's actually the first time I've ever been in Aberdeen, and that's a lovely evening, so it's great to be here. When you go home this evening and you go back into your living rooms, you might think, it's a bit chilly in here, I've got to do something about this, I want to increase the temperature in my living room. So there are a number of different things you can do. You could turn up the radiator, you could shut the window if the window's been open, you could light a fire, you could maybe put a draft excluder, or you could shut the door, you could put a draft excluder at the bottom of the door. The point I'm making is that the climate of your front room does not simply depend on one thing. It doesn't simply depend on the radiator, the fire in the grate, or the open window. And this planet, which is our home, on which we all depend, is in many ways a very large and complex living room. And the temperature that planet, the mean temperature of that planet, is dependent on very many competing and different influences. And sometimes the way in which those different mechanisms interact can be quite complex. And that leads the science in some places to be somewhat uncertain. But there are other aspects of the science that are much more certain. So, I'm basically a scientist, and I fundamentally work with evidence. And all my statements this evening on the science will be based on the evidence, and I challenge David to ensure that all his statements are also based similarly on evidence. Furthermore, and I think this is a very important point, all the statements I'm going to be making will be made on the basis of a scientific understanding of the totality of that evidence and not on any cherry-picked component of that evidence to make a case. Science is not fundamentally adversarial. Science requires scientists who are honest souls to look at the totality of the evidence and to make their conclusions based on that totality. So I won't be cherry-picking tonight. There are uncertainties, and where there are uncertainties, I'll be quite clear about what those uncertainties are. What I want to argue this evening is that the fundamental science concerning climate change is actually settled. And the real debate needs to be about what we're going to do about it, about adaptation, about mitigation, and so on. The scientific community, there is a consensus within the scientific community that the fundamental science that human emissions, notably of the major greenhouse gases, are materially influencing the temperature of the planet. That is fundamentally a settled position. When I move into the area of policy concerning adaptation and mitigation, I'll be speaking not only as a scientist, but also going beyond that as a citizen of Wales who is very familiar with the science, but as a father and somebody who has great concerns about the future of the planet. So I'll be moving beyond my role when I'm talking about policy. Fundamentally, the major problem that we have is carbon dioxide, emissions of carbon dioxide going into the atmosphere as a result of, above all, fossil fuel burning, but other processes as well. And actually, I'm just going to get a pointer because I need to point to just right. Okay. What we've got in this diagram is this is the wavelength of radiation coming into and out of the Earth's system. The sun produces what we call short wave radiation. This is the smaller end of the radiation wavelength, and that radiation comes into the Earth's surface and warms up the Earth. The oceans absorb that radiation, the Earth's surface absorbs that radiation, and that radiation is then re-radiated back out of the Earth's system. But it's re-radiated back out at a longer wavelength than the wavelength with which it came in. And the really important take-home message is that there are certain components within the atmosphere, there are certain components within the makeup of the atmosphere that absorb components of what we call that long-wave counter-radiation, that long-wave radiation that's going out. So, for instance, we have nitrous oxide, methane, carbon dioxide and water vapour. And here you can see, that's carbon dioxide. There you can see the wavelength of this long-wave counter-radiation, which the carbon dioxide is absorbing. The carbon dioxide absorbs that counter-radiation within that very specific part of the wavelength. And it's that trapped counter-radiation that is serving to heat up the Earth's system. So the proportions of any one of these, or the combinations of these greenhouse components, will serve, if they increase, to warm up the Earth's system. Now, carbon dioxide is, in this sense, you might think it's a bad thing, but actually carbon dioxide is a very good thing. Because if we didn't have any carbon dioxide in the atmosphere at all, the equilibrium temperature of the Earth's system would be between -15 and -30 degrees centigrade. With the kind of levels of carbon dioxide the Earth's system has experienced before human activity, that means that the equilibrium temperature of the Earth is about +15 degrees centigrade. That means that we have liquid water on the surface of the Earth, and there wouldn't be life on Earth as we know it without carbon dioxide. But we can have too much of a good thing, and we are currently having too much of a good thing. The kind of science that I come from has produced these very long records of carbon dioxide over the last up to 1 million years. This is actually 800,000 years. And we now know that from records from, in particular, Antarctica, this is records of ice cores taken through the Antarctic ice sheet, whereas the snow, when it increases in density every year, increases in density gets buried, the air within the fabric of the snow eventually turns into discrete air bubbles. And those little air bubbles are little samples of the atmosphere at the time that ice was created. And as you go back in time, this means that you can reconstruct the CO2 content of the atmosphere. This is where we are now. We're at about 400 parts per million CO2. You can see the context of that. This was the last glacial maximum, that was the last ice age, that was the last interglacial, that was the glacial before it. Every time we have a glaciation, a major ice age, we have about 180 parts per million. Every time we have one of these interglacials, which we're actually now in, naturally, we have levels of about 280. We're now at 400. We know from the ice core record that is unprecedented in the last 800,000 years. And all the available evidence would suggest that the last time we had values approaching 400 was about 3.5 million years ago in a period called the Pliocene, when global sea levels were about 25 metres higher than they currently are, because the major ice sheets were much, much smaller than they currently are. So, atmospheric CO2 concentrations have increased by about 40% since 1750 due to human activity. We know that that is due to human activity because there are fingerprints within the carbon dioxide. It's what we call isotopically light. It's the kind of carbon dioxide that is produced from fossil fuel burning. And we can see that not only in the atmosphere, we can see it getting into the oceans as well. So we have fingerprints that it's actually being sourced by human activity. So that's the context of the CO2 concentrations we now have. I'm going to show you now a short animation which shows you over recent years the actual measured values of carbon dioxide, and then it shoots back in time to give you more or less the same graph that I've just given you. And what you'll see here is, so you can interpret it, this is latitude, this is 90 degrees south, so this is the Antarctic, this is 90 degrees north, so that's the North Pole. And what you'll see is that these are the values, 330, 340, 350, 400 is up there. This is the value of CO2 in the atmosphere going through time. And the year that is being measured will be shown there, and the measurement stations will be shown there. What you'll see is it goes up and down quite a lot seasonally, and that's because most of the continents are in the northern hemisphere, and as they green during the spring, which we're currently going through, lots of vegetation grows, and that, through photosynthesis, that actually takes CO2 out of the atmosphere. So there is quite a strong annual seasonal fluctuation to this. That's not matched by any photosynthesis in the southern ocean, because we haven't got the continents to actually generate that growth of plants. So what we can see, this is 1980. You'll see that the mean values will go up inexorably. But in the northern hemisphere in particular, we have this signal of a seasonal bounce. We have a seasonal effect. This is a graph that is producing the mean value, and then you've got the seasonal value superimposed on that. So that's 1990. Just coming into the year 2000 now. These are all values based on direct measurements of the CO2 concentration in the atmosphere from all these different stations around the world. So that's gone up to 2011. And what it does now is it goes back from 1980, back through the recent decades. So this is the graph we look at now. So it's back to 1960. Now it's going back, this is now data from the ice core record. It's data going back through the last millennium. That's the year AD 1000. So you can see the values compared to where we are now. This is the last glaciation, values of about 180. That was the last interglacial. Values of about 280 or so. And then back through the last few ice age cycles, going back to 800,000 years before present. So there you can see the context, that's where we are now. That's the natural context. That's the splicing together of the instrumental data with the ice core data. CO2 is important. I've described it as a greenhouse gas, the effect that it has in traffic counter radiation. This is carbon dioxide here, that's the last glacial maximum. This is the same graph I've just shown you. This is the radiative forcing, this is watts per metre squared. This is the impact that that greenhouse gas has on every metre squared of the Earth's surface, and it's compared there with other increases in methane and also nitrous oxide. So it has this we know physically, from the physics of this, it has this radiative potential to increase the temperature of the Earth's system. Now I said that there are lots of different factors involved. If you look at the climate of the last millennium, the last 1,000 years, that is the recent warming in the context of the climate of the last 1,000 years. CO2, greenhouse gases are important, and this is again the last 1,000 years. There you can see the increase in greenhouse gases that I've just been describing. But other factors are important. The output from the sun is important. So there's solar variability, there are sunspot cycles. The radiation emitted from the sun varies through time. We have a handle on that through the last 1,000 years. Volcanic emissions, volcanic eruptions also have a dramatic impact on the climate, notably by cooling it down because of the particulates, the dust that go into the atmosphere. We also have a handle on the major eruptions that the Earth has experienced. Those are the only three forcings that are really important to us at the present time and over the last 1,000 years. Volcanoes, the output of the sun, and the greenhouse gases. Now we have coupled models where you can put these forcings in and you can look at the response of the Earth system to those forcings. Basically, three mechanisms that change the climate of the Earth system. You can run models with just one of those, with just volcanic emissions, with just greenhouse gases. You can combine them together. And by doing that, you can actually analyse which is the most significant of these three forcings for the warming that we're now seeing. If you do that, these are all the predictions from the model simulation of this series of observations. And these lines here, which do not predict the warming since about 1850, are the simulations that leave out the greenhouse gas forcing. That is what would have happened to the Earth system without anthropogenic, without human-induced CO2. We would simply not have seen the warming since 1850. The warming since 1850 can be analysed in this way and can be attributed to the greenhouse gas flux from anthropogenic emissions, and we know that's a result of largely industrial activity. So the latest assessment report of the Intergovernmental Panel on Climate Change concluded, and they have these terms like extremely likely, which are based on statistical analysis of the data. There's a 95 to 100% probability that most of the observed increase in global surface temperature since 1951 has been caused by human influence. And I can give you the figures, but they basically are attributing that to the greenhouse gas contributions which I've just told you about. And that report went further and it projected on the basis of different amounts of CO2. We may be able to control CO2 going into the atmosphere in the future, we may not. So they run a series of models based on different scenarios, and this is a projected global average surface temperatures in 2100, where we have where there's a lot of CO2 going into the atmosphere and ones where we actually basically stop it now. And you can see the projected increases for these different scenarios. 0.3 to 1.7 increase in global surface temperatures. Even if we stop all the CO2 where we are now, there's going to be a significant increase in global surface temperatures. This is a very important take-home message, and that is that the warming will not be the same everywhere. The globe will not warm up the same amount everywhere. And under these different scenarios, that's the rather low, that's the stop CO2 now, this is the high CO2 scenario. Even in that you can see lumps and bumps. You can see places where it's going to warm much more over the continents and over the oceans, particularly in the high northern hemisphere in the Arctic. And you can see here that there's a bit in the North Atlantic which is going to warm it may even cool slightly. It's not going to warm at the same rate. And that's because of changes in ocean circulation, which I can talk about later if you wish, but there are going to be regional differences. And that's very important, because if you live in a particular place and your experiences of the weather and the climate is of that particular place, that may not be typical of the whole Earth system. I'm interested in what is happening in the whole Earth system. Here we have another animation. This shows how variable geographically across the Earth's surface. These are just observations of what's happened since the 1880s, going through to more or less the present time. And what we can see is you can focus on a particular area of the globe, a particular area of the Earth's surface, and you can see areas which are not warming. This area, for instance, in the early 20th century wasn't warming to the same extent as the global mean. These areas that are in yellow and red are warming at a faster rate than the global mean. And these trends, these regions can buck the trend for decades, for a decade or two. And this is part of the natural geographical variability which underpins this general trend towards warming. This is 1987, we're coming up towards the present period, and what you'll see is this amplification of warming in the Arctic, in the high northern hemisphere, which is really pronounced now. So it's very variable in space. It's also variable in time. So an individual experience may be very different, even at the scale of the British Isles, from the global mean. Climate change isn't something for the future, however. Climate change is actually happening now. There are expressions of significant changes to the Earth system which are now being observed. The Arctic sea ice reduction is one of the most prominent of these. In fact, the area covered by the sea ice, this is the frozen lid of the ocean. This is not glaciers on land, this is the frozen lid of the ocean. The extent of it and the thickness of it has diminished at its summer minimum significantly over recent decades. And in fact, it's diminished at a faster rate than even the most extreme models predicted. And this is really important because the ice reflects this incoming solar radiation from the sun. It bounces off, it goes back out. If you take that away, you have a dark ocean. That dark ocean absorbs all that incoming solar radiation. And so this is what we call a positive feedback effect. It's amplification of that tendency. So the ocean is warming up at a faster rate than other parts of the system in the Arctic because of the reduction of the sea ice. I'll flip on. We're also seeing changes in sea level. Global mean sea level is rising by 3.2 millimetres per annum as a result of melting glaciers and the expansion of the upper part of the ocean. Again, that is spatially quite variable. Some parts of the Earth, of the ocean, are rising at a much faster rate. Some areas, here for instance, that is actually, the sea level is actually falling, but the mean is rising, and the rate of rise is increasing. So this is my final slide, ladies and gentlemen. The implications of the changes I've been talking about are the most profound changes and the most significant crisis that I believe we currently face. It's not going away. The geopolitical situation and the economic situation recently has pushed it to some extent to the back of the agenda, but it's not going away. It's a really significant issue. This just shows one of the impacts. This is the spread of malaria as a result of changes in the temperature of the Earth system. There are all sorts of implications in terms of disease, society, societal pressures, and so on. So I'll end there.
Well, can we leave that now?
Yes.
Thank you, James. He was rolling. To be fair, you had 25 minutes. It's all right. David, if you need 25, you can have 25. As you say, there are two sides to the argument, and as you know, folks, today was a good day to have this debate. The IPCC report came out in the last 24 hours, and the IPCC chairman, and forgive me if I say this incorrectly. Rajendra Pachuri said, "The effects of climate change are likely to be severe, pervasive and irreversible. As the world warms, major crops will fail. Rising sea levels will force hundreds of millions of people to leave their homes. Nobody on this planet will be untouched." However, Matt Ridley in the Wall Street Journal said, "The IPCC has a rotten track record for accuracy. Its last major report in 2007 was riddled with errors. This one depends on too high, too fast assumptions." Even Richard Toll, the economist, who served on the IPCC panel, said, "This report has an unnecessarily alarmist tone." Over to you, David.
Thank you very much. First of all, can you all hear me at the back? Yeah, okay. Right, well let me rise to Professor Scalz's challenge, because he wanted me to guarantee that everything I say is factually accurate, and as far as I can tell, it is. He wanted to say that everything he said was factually accurate. Much of it was, but there was a little bit of conjecture, if I may say so, to the end, and I'll come back to this as well in a moment. As far as the facts are concerned, James, if you don't mind me calling you that, has spent a good few minutes persuading us that there's been an increase of carbon dioxide emissions, and he's absolutely right. I didn't need any persuading about that one. We started to industrialise at the end of the 1700s, and in doing so we started burning coal and then gas, and subsequently we have increased our carbon dioxide emissions. No doubt about it whatsoever. The second point is, and it was there on your first slide, CO2 is one of the gases that creates global warming, a very important one as well. And, absolutely no doubt in my mind about that, although you perhaps could also have mentioned that water vapour, which was also on your graph, is a much more important one as far as heating the planet is concerned. But CO2 definitely is a global warming gas. There's more of it, and there has been an increase in temperature over the last 250 years. I've seen two figures now. The generally stated figure up until the last IPCC report was 0.8 degrees, but they seem to have downgraded it now to 0.6 degrees. Anyway, it's one of those two figures represents the total amount of warming that's taken place. There is no doubt about that. And so it follows naturally that some of that warming that has taken place is as a result of mankind's emission of carbon dioxide. And of course, the climate may well have changed as a result of it. The climate has always been changing. I've never yet met any scientist or anyone who denies climate change. I mean, I often get labelled a climate change denier, and that's absolutely ridiculous. Because the one thing I think we can all agree upon is that the climate has been changing ever since the Earth was created 4.5 billion years ago. Many of James's slides made that point when he showed the last glacials and interglacials that's been going on ever since the Ice Age which we're currently in, don't forget, started roughly 247 million years ago, I believe, is the figure that's given. There we are, not too far out. So there's no doubt about some of the science. The real question that we need to ask ourselves is how much of this warming that we agree has taken place is as a result of man-made carbon dioxide emissions, and how much has come from other factors. And even James admits that there are plenty of other factors that are affecting that forcing. We know, for example, from study of the climate over the last 2,000 years, that there have been periods when it's been warmer and periods when it's got cooler again. It was warmer during the Roman times, during the Roman optimum, and then it got cooler. And then it got warmer again during the, not very originally named, medieval warming period, which happened, funnily enough, during the medieval times. And then it got cooler again. And we had this episode called the Little Ice Age, when it became very cold indeed, and all the paintings show the Thames all frozen over and the ice fairs that were going on there. We know that was a very cold period, and it ended round about the start of the 19th century, which was the time that we started to industrialise. And so the point I make is that some of this warming, some of this relatively small amount of warming, 0.6 degrees, must be due to the fact that we were coming out of a cool period. And no scientist has ever been able to tell me how much of it is down to that. We know that the cycles that have been taking place over the last 2,000 years are part of wider cycles that go on. We know that roughly in this ice age that we have now, we've had a glacial for roughly 100,000 years, and then we've had around 10 or 11,000 years of an interglacial when it's become warmer. And we actually are coming to the end at the moment of an interglacial. At least we're 10 or 11,000 years into one, so it's quite possible that it's going to start getting colder again sometime soon. We know that there are all sorts of cycles going on, and we don't really know what role these are playing on the small amount of warming that's taken place over the last 250 years or so. One would expect, if everything James is saying is correct, and that, as I think you're saying, that the CO2 is entirely responsible for the warming, or mainly responsible for it, one would expect to see a graph showing an increase in CO2 matched by an increase in temperature. But we didn't have that graph here today. And if we had, we wouldn't have seen a straightforward correlation. Because what's actually happened over the last 250 years, as James has showed, there has been an increase in CO2. There hasn't been a straightforward increase in temperature at all. In fact, over the last century, we know that between 1940 and 1970, the temperatures were going down. Despite the fact that a lot of CO2 was going into the atmosphere, it was getting colder. Which is why actually so many people, when I was young, thought that a new ice age was actually coming. It was about time we had one, and it did seem to be getting a lot colder. Then suddenly in the 70s it started getting warmer again, and people began to assume that CO2 was the culprit from about 1988 onwards, when the IPCC was formed. And all sorts of policies were suggested to try and deal with the rising carbon dioxide. But then they hit a bit of a problem, didn't they, James? Because there hasn't been any increase in temperature globally since 1998. There has been no increase in temperature for the last 17 years, and that is despite the fact that there has been massive amounts of industrialization going on in the world. In China, where they're building a new coal station virtually every week. In India, in South America, they're industrializing like crazy, and still no increase in temperature. And the IPCC have been running around, not trying to rethink their whole theory, but trying to come up with all sorts of reasons as to why it is that there's been no increase in temperature over the last 17 years. Now, all I would suggest then is that there is plenty to question as far as the science is concerned. But I know most of the people in here are not my supporters. I was very, very happy to have all the environmentalists coming, and I'm going to come to this in a few minutes because I think we need to have a bit of a conversation. So I'm going to assume that most of you buy the science 100%, and that's fine if you do, because even if you believe everything that Professor Scholes has said is absolutely accurate, even if you dismiss the fact that the IPCC have been getting it wrong in one report after another when they've reported increases in temperatures, there is still another problem, and that is the economics of the policies which we're carrying forward at the moment. It's not simply an environmental argument, it's an economic argument as well. And the latest IPCC reports were very interesting because they're actually, to my mind, a lot more reasonable than the previous ones have been. If I can find the right documents here, the IPCC have predicted that if global temperatures rise above 2 degrees, and this is Working Group 2, page 19, for anyone who wants to check the facts, we do need to be accurate here. They've suggested that the total cost of this could be 2% of global GDP. Well, that sounds like a lot, obviously 2%. But let's remember, that's 2% of global GDP at the end of this century, nearly almost 90 years hence from now, when the whole world is expected to be far wealthier than it is at the moment. In fact, their predictions are based on the fact that all of the developing world will have developed, that wages will have caught up with the West, and that everyone will be driving cars and enjoying a similar sort of lifestyle, which is also a prediction that most economists make as well. So I think it's a fairly reasonable one as it goes. In other words, their predictions are based on the fact that there will be greater carbon dioxide emissions because we will live in a much richer world. And yet the other working group of the IPCC, which is, if you'll forgive me for a moment, I think it must be Working Group 2, but I haven't got it to hand. But anyway, Professor Scholes no doubt correct me if I'm wrong. They have tried to calculate the cost of mitigating climate change, in other words, by decarbonising all the economies. And they've come up with figures of 1 to 4% of GDP right now. So from an economic point of view, we're being asked to take a cut of at least 1%, but possibly 4% in our GDP, in order potentially to ensure that a world in 85 years' time, 90 years' time, which is already going to be much better off than we are now, are going to be even better off still. And that to me doesn't make economic sense. I wanted to see this last one up here, because the point about malaria, ladies and gentlemen, is not a disease that is suffered by people who have high temperatures in their countries. It is a disease suffered by the poor. That is why you had malaria in this country 100 years ago, in the times of Charles Dickens. It's why you never get malaria in countries like Singapore. It is a disease that will affect people if they're worse off. But on the IPCC's own predictions, the world is going to be far better off in 100 years' time than it is now. And I think that's a very good thing too. Okay, that's the economics of it. It doesn't make any sense to start giving away 4% of your economy in order to save 2% in 100 years' time. But maybe you don't believe that either. I'm sure you're a very sceptical audience. So even if you think that it does make sense to decarbonise now and that the science is all correct, there's a third problem that we have, which is that we're being asked to do this only in the United Kingdom. We're responsible only for 2% of the entire emissions of carbon dioxide across the whole of the world. And yet the governments, both governments really, have come up with all sorts of ideas to try and decarbonise. We've got emissions trading going on, renewable obligation certificates, feed-in tariffs to try and make sure that everyone has renewable energy, wind farms all over the place, and so on and so forth, all of which is costing a lot of money, all of which is only being done in the United Kingdom. And I appeal to all of you, just think about this for a minute. We're making it more expensive for people to have electricity and gas, which you may think is a good thing. We're also making it very, very difficult for manufacturing industries. Companies like Celso, who I've spoken to this week, who are saying to me, well, what's the point of doing business here? We can take our business elsewhere, we can make things in other countries, the wages will be cheaper, but not only that, but the energy is going to be a lot cheaper as well. It doesn't make sense to invest in manufacturing industries in this country, particularly if they're going to be high users of electricity, if they're in ceramics, steel, or anything like that. We're destroying our manufacturing base, and we're not doing anything about carbon emissions. And that really brings me to the environmental movement. I'm sorry that some of the people like Rod aren't here today, because I have a great deal of respect for him, and he can't make it tonight. I know he's been very active in Abergavenny Friends of the Earth for years, and he used to come in to see me in surgeries, and he talked to me about climate change and about Israel. And the funny thing is, I've changed my opinions on both. In one on the Israel one, I'm coming closer to him. On this one, I've come a lot further apart from him. But what worries me is the inconsistency that I see from the environmental movement. Okay, you buy the science. You buy the economics. You believe that we've got to decarbonise, and you're prepared to do it in the UK alone. I get that, although I disagree with you. But there are a couple of things that we can all agree could be done to decarbonise, which most people will not even think about. We could be thinking about nuclear power, which will generate very large amounts of electricity at a predictable price, in a predictable way, without any carbon dioxide emissions. And yet the Green lobby are completely and utterly opposed to it. We should be thinking about the 7th barrage. I have an open mind about it. I think it probably could end up being a little bit too costly. But when Gareth Chubb came in, who is Friends of the Earth's, I don't know what he's called, but parliamentary advisor, he came into the Welsh Affairs Select Committee completely closed-minded about it, even though it could generate 5% of the UK's electricity without any carbon emissions, and to boot, wanted to give all of his evidence in Welsh and was refusing to give written evidence in English, which obviously was more important to him than the future of the planet. And then there's the issue of fracking, which I know is also very controversial. But again, the IPCC have made it very clear. If we're going to move to a low-carbon or a decarbonised economy, we have to be willing to adopt technologies that will get us there. We have to be looking at getting rid of coal stations, which is a shame, but replacing them with gas for the interim period. We're sitting on large amounts of gas in this country, and yet nobody opposes it more than the environmental movement. Well, there are some people actually who are even more opposed than the environmental movement. I'm sorry that the gentleman who spent a few months in Russia isn't here today, the one who, from Friends of the Earth, maybe is, from Kolikon. He was one of the people who raided the Gazprom platform. You all remember that? And he's been giving talks. I'm looking forward to meeting him, because I've got a really good question for him. Does he realise, does anyone in Friends of the Earth realise that some of the people most opposed to fracking are the directors of Gazprom? If you have a smartphone, you don't believe me, Google Gazprom directors, fracking. Oh, they're ever so worried about the environmental consequences, or at least that's what they say they're worried about. You and I, we're all a bit wiser in this room. I suspect what they're really worried about is because if the UK, Poland and large parts of Central Europe can suddenly get their hands on their own supply of gas, they're not going to need Gazprom anymore. There's only one country in the world, more than any other, that's cut its carbon emissions, and that's the United States of America. And they weren't even trying to cut carbon emissions. They did it because they got rid of their coal-fired power stations and switched over to shale gas. Although, of course, now they're selling the coal to the rest of the world. So really, what I have to say is this. It's not me I'm not going to persuade you, and you're not going to persuade me. These things are going to get decided out there. At the moment, politicians have taken the message loud and clear from everyone, and that is that the issue that concerns most people isn't global warming, it's the price of their electricity bills. Seems to be what's worrying Ed Miliband at the moment. David Cameron's saying the same thing. That's become the big political issue. And do you know what? The biggest disappointment that I ever had was when I noticed that Friends of the Earth were launching a campaign against high fuel bills. You must surely realise that if we're going to switch from sources of electricity generation which are quite cheap like coal or even gas and start using renewables, there is going to be a cost. And if Friends of the Earth and all Greenpeace and all the other environmental movements are not even willing to make the argument, and worse than that, are actually going to condemn anyone who's responsible for higher fuel bills, don't expect any of the rest of us to do it. I'm sorry if that's a little bit harsh and direct, but you know, I'm known for speaking my mind. I want to see a greener world, yes. I support energy diversification. I believe that it's a good thing from the point of view of energy security. I would also like to see everyone having affordable electricity and gas bills, and I want to see a good, strong manufacturing sector. And I make no apologies to anyone for that. Thank you very much.